Yo guys, welcome back to this channel. Nice to see everyone again. Make sure you have subscribed to this channel for more informative chemistry videos. And for this video today, we are focused on your topic 6 talking about carbonyl. So in this topic, we have 4 subtopics to cover. The first one is the general structure of carbonyl. And then we are looking at the IUPAC naming as always. Moving to the preparation of carbonyl. Last but not least, talking about the chemical properties of carbonyl, the same thing. And talking about carbonyl, we have 2 homologous series, which is your ketone and also aldehyde. So in this video, we'll look into ketone and aldehydes in detail. Let's jump straight into the general structure of carbonyl. The main thing, the functional group over here is your carbonyl. So when the functional group is carbonyl, the carbonyl is actually your C double bond O. And everybody knows that the carbon can have 4 bonds. So the another 2 bonds that the carbon have will be attached to what? It will depend on the homologous series of aldehyde or ketone later on. But the carbonyl itself represents C double bond O. So the functional group that we will focus in the entire topic is the carbonyl functional group, which is your C double bond O. And let's move into the detail of it. We have aldehyde and also ketone. So why aldehyde and ketone both is under the same topic? Because both having the functional group carbonyl. Your aldehyde ketone both will be holding C double bond O. But the question is, where is this C double bond O located? So in your aldehyde, your C double bond O must be at the last carbon. In the other words, your C double bond O over here must be holding at least 1 hydrogen. That represents this carbon is the last carbon. Alright? Whether it's the first carbon or the last carbon is the same. It doesn't matter. As long as the carbon is holding at least 1 hydrogen. And that is your aldehyde. So remember, your aldehyde means your C double bond O group over here must be holding at least 1 hydrogen. The another bond over here can be attached to your R group, and your R group as always is your alkyl group, which is your carbon group. And we don't care how many carbon is that. It can be a straight chain, it can be a ring, it doesn't matter. What matter over here is your aldehyde holding C double bond O and holding hydrogen directly attached to the C double bond O. That is your aldehyde. Next, let's look into ketone. So, ketone, the C double bond O must be in between carbon. So, look at it guys. That is my C double bond O over here. And you can see that your C double bond O is attached to 2 R group. And we know that your R group is your alkyl group, which is your carbon group. So that is actually your carbon, that is actually your carbon. So your ketone over here, the C double bond O will be in between carbon, in between carbon. And that makes your aldehyde and ketone different. It's actually the position of C double bond O. Aldehyde, you must holding hydrogen. Ketone, you must be sitting in between carbon. Make sure you understand this. This is the most basic thing that you need to know in the topic 6 carbonyl. Alright? Simple. Some example for aldehyde. Your aldehyde can be as simple as your CH3 holding C double bond OH. That is your aldehyde. Your aldehyde can also be a longer R group or a bigger R group with more branches, as long as the carbon that holding double bond O must be attached to at least 1 hydrogen. And that is your aldehyde. The presence of your carbonyl group attached to at least 1 hydrogen. That is your aldehyde. Your aldehyde can also be when it's attached to a ring. So you can have your C double bond O attached to hydrogen. And that is still your aldehyde. Your aldehyde can also be when it attached to your benzene ring. So you're having your benzene ring with your C double bond O holding hydrogen. And that is also your aldehyde. As long as the C double bond O holding at least one hydrogen, all this will be categorized under the homologous series of aldehyde. Okay? Simple. Some example for ketone. Ketone means the C double bond O must be between the carbon. So the simplest ketone that I can give to you is holding one carbon, one carbon. That is your ketone. Your ketone can also be holding a straight chain on the left, holding a C double bond O and a cyclic on another side, because that is also your carbon. So this is also your ketone. Your ketone can be holding also your benzene ring. Holding your benzene ring with a C double bond O and another carbon group. That is also your ketone. And as long as your C double bond O is sitting between carbon, that will be done under homologous series of ketone. Okay? So aldehyde, C double bond O must be holding one hydrogen. Ketone, your C double bond O must be sitting in between carbon. Easy? Simplest thing ever, right? Next, moving to the 6.2, where we talk about the IUPAC nomenclature of aldehyde and also ketone. And we shall start the naming of aldehyde. Just a kind reminder, aldehyde means that the C double bond O must be at the last carbon holding one hydrogen atom. Okay? And the parent name of aldehyde is as simple as changing the E of the methane to Al at the back because of the aldehyde. So from methane to become methanol is actually one carbon aldehyde. One carbon aldehyde looks something like this. Another example, you have your ethane, A and E, the E at the back changing to Al over here. Ethane to become ethanol is your 2 carbon aldehyde. So that is your aldehyde. We already have one carbon, another carbon CH3. So that is your ethane to become ethanol, 2 carbon aldehyde. Another example, you have your butane, E, to become butanol. So changing the E to the Al due to the Al over here is a 4 carbon, therefore start off with your C double bond O first, holding the hydrogen. Use up 1 carbon over here, I will have 3 more carbon, CH2, CH2, and CH3. So that is my butanol. Simple, easy. And I hope you realize one thing. Since in aldehyde, your C double bond O must be at the last carbon, so you realize that your C double bond O over here will always be at the last carbon. Okay? And therefore, a kind reminder, who should get number 1? Who will have the lowest number over here? Obviously, your C double bond O. Your C double bond O over here must be the carbon that holding number 1. Always. Okay? Don't worry about that. We'll go through more example on the naming later on. So let's move on to some common name, some famous common name that we always use in the exam. The first one, if the IUPAC name is methanol, the common name is actually formaldehyde. So methanol, we know that is a 1 carbon aldehyde. So that is your methanol, 1 carbon. And this compound is also named as formaldehyde. Okay? Another common name is your ethanol, which is your 2 carbon aldehyde that looks something like this. So that is my 2 carbon aldehyde, and the name also can be called as acetaldehyde. So that is the common name of your ethanol. Last but not least is the one that we come across previously. If the IUPAC name is your benzene carbaldehyde, that is actually your benzaldehyde, where you have your benzene ring holding the aldehyde group directly attached to the benzene. So that is your benzene carbaldehyde. as your IUPAC name, but the common name is actually your benzaldehyde, one of the most famous common name that we always use. So I have additional two over here, which is your formaldehyde and your acetaldehyde. Okay, that is the common name that we always use for methanol and ethanol. Make sure you know that. So for the naming, for the IUPAC naming of aldehyde, there is only one rule. The rule is the C double bond O, the CHO over here represents C double bond OH. So the C double bond O in the longest parent chain must be number 1. Since it's aldehyde, the C double bond O will definitely be at the last carbon. So the C double bond O must be number 1. Okay? Let's try some example. So as always, to find the longest carbon chain, how can we find the longest carbon chain? Simple. Start with the carbon that holding double bond O. Okay, so that is our carbon. Moving to the left, and then the left right now having branch. Going straight or going down will give you more carbon because we want the longest carbon chain. So obviously, moving to the left will give you more carbon. So that is my longest carbon chain. And guys, who deserves number 1? Are we counting from the left or are we counting from the right? In this case, we definitely count from the right because the C double bond O is located on the right. So 1, 2, 3, 4. And you have a substituent over here. This substituent is your 2-methyl group. And your parent is a 4 carbon, which is your butanol. And my question over here, do we need to put number for the butanol? Do we need to write 1 butanol? Is that needed? It's not needed because your C double bond O will be forever at number 1. Always. Alright, in your aldehyde, we do not need a position for your parent because your C double bond O will be forever at number 1. Remember that. So the full name of this compound will be 2-methyl butanol. And I hope you remember the basic rule of IUPAC naming. When is the time using dashes? When is the time that you combine with no space? And so on. Just a kind reminder, all the rules and regulations that you learned previously will apply exactly the same. The name and the position of the substituent, arrange alphabetically order the prefixes di, tri, tetra for the same substituent, the comma when you are having numbers, the dashes when you are having numbers and alphabet, also the longest parent chain with most substituent. And the only rules that we add in is your C double bond O in the parent chain must be at the lowest number. That is the only thing that we added in this IUPAC naming. The rest will be the same as before. Alright? So all the rules is the same. Only one thing. The C double bond O must be at the lowest number. Easy. Let's move on to another example. So I have a structure over here. As always, we know that the C double bond O must be the parent. Always start with the carbon that holding C double bond O. And then moving to the left again. Going to the left or going down. Obviously, going down gives you a lot more carbon. So move down. And then you have branches again. Going to the left, going to the right, or going down again. Look at the number of carbon. We always go to the side that give you more carbon because we are looking for the longest carbon chain. Put in the position. C double bond O over here must deserve carbon number 1 because it's the parent, it's the boss. So 1, 2, 3, 4, 5, 6. And since there is 6 carbon in this longest carbon chain, this guy will be named as hexanol. 6 carbon aldehyde. Next, how many substituent you have? You have over here 1 substituent, 2 methyl group. Another one, 3 methyl group. Another one over here on the same carbon. So 3 methyl group is the same substituent. what prefixes are we using? The prefixes will be trimethyl with 3 position in front. So 2, 3, 3 dash trimethyl hexanal. Easy, simple, alright? Let's try another example. Same thing, we will start with the carbon that holding C double bond O. Always start with your boss. That is the one that must be in the parent chain. Moving up right, we can go to the left, we can go to the right, or we can moving up right again. Look at the side that gives you more carbon. On the right, I only have 1 carbon. On the top, we have 3 carbon. On the side, I have 5 carbon. 5, 3, 1. Obviously, going to the 5. And then you have another branches, another selection, going straight to the left or going up right. Up right, there is 2 carbon. Going left, there is only 1 carbon. So obviously, going up right again. And that is my longest carbon chain with the C double bond O in the longest carbon chain. And position it, knowing that your C double bond O must be number 1. So 1, 2, 3, 4, 5, 6. 6 again, therefore the parent over here will be hexanal. We have 3 group of substituent. The first one, you have your 2-methyl group. Over here, 4-methyl group. Next, what is this, ladies and gentlemen? That is your 2-isopropyl group. And you have 2 similar substituent. Therefore, it will be 2,4-dimethyl. Just a kind reminder, alphabetically order of isopropyl, we will take count of the I. Dimethyl, we will take count of the M. And alphabetically wise, M come first or I come first. Obviously, I come first. Therefore, 2-isopropyl, 2,4-dimethyl, hexanal, 6-carbon aldehyde. Easy? Simplest thing ever. Next, what happens when your aldehyde is attached to a cyclic? The name will be quite special because you will be having the name of the ring followed by the word carbaldehyde. You will have the name of the ring followed by the word carbaldehyde. So the first example that I have over here, you can see that your C double bond O right now is directly attached to your cyclohexane. That is my cyclohexane 6-carbon. 6-carbon ring with a C double bond OH attached directly. So what will be the name of this guy? This compound will be named as cyclohexane carbaldehyde. Okay, cyclohexane carbaldehyde. Bear that in mind, no space over here. That is what I mean by the name of the ring followed by the word carbaldehyde. Okay, next, another example. I have a 5-carbon ring over here. So that is my cyclopentane. And having an aldehyde attached directly to the ring. Bear that in mind, directly to the ring. So it will be cyclopentane carbaldehyde. And that is how we name when your C double bond OH attached to a cyclic. Bear that in mind, it must be directly attached to the cyclic. Okay? Simple? Easy. Some example over here. So, obviously, this will be the parent. Where the parent over here is your cyclohexane 6-carbon with the aldehyde. So, carbaldehyde. With a condition, your aldehyde C double bond OH directly attached to the ring. So cyclohexane carbaldehyde is the parent. Who do you think will get the number 1? Obviously, the carbon that holding the aldehyde. this will be carbon number 1. And as always, going clockwise or anti-clockwise, it doesn't matter as long as the rest of the substituent get the lowest number. So obviously, moving to the right. 2, 3, 4, 5, 6. And the substituent over here is your 3-ethyl group. Over here, 4-methyl. And alphabetically order M and also E. Guys, M and E, who come first? 3-ethyl, 4-methyl, cyclohexane, carbaldehyde. That is the name of this organic compound. Simple. Just a kind reminder, the parent name is the name of the ring followed by the word carbaldehyde, and also the carbon that holding the C double bond O, this carbon must be carbon number 1. Okay? Then only you choose moving to the left or moving to the right to ensure the rest of your substituent also get the possible lowest number. Let's try another example. The question over here right now is in the form of skeletal. You can expand that a bit. That is actually my carbon. Carbon holding C double bond O, having 3 bonds, so 1 more is actually your hydrogen. This guy is actually your CH3. Over here is your C, holding C, holding C. And this is having 1 hydrogen to make sure that they have complete 4 bonds. 1, 2, 3, 4. CH3, CH3. I hope you can see what substituent it is. So the parent will be the cyclic with the aldehyde. So the name over here, cyclopentane carbaldehyde. So the substituent that I have over here, methyl group. And the substituent that I have over here, isopropyl. The problem right now, what is their position? So always remember the carbon that holding the C double bond O must be carbon number 1. Moving to the left or moving to the right? Moving to the left because your substituent will come across the lowest number, which is number 2, 3, 4, 5. So your methyl group will be carbon number 2. Your isopropyl will be carbon number 4. Same thing, alphabetically, M come first or I come first. Obviously, I come first, therefore, 4-isopropyl, 2-methyl, cyclopentane, carbaldehyde. And that is the complete name of your aldehyde that directly attached to a ring with some substituent. Simple? Easy. So I hope right now you can write the name of your aldehyde that attached to the ring. Okay? Let's look at another example for aldehyde before we move on. Looking at this structure right now, guys, my question, are we going to have the parent as cyclohexane carbaldehyde? Alright, is this a C double bond OH attached to a ring? No. Why? Because the C double bond O and H is not directly attached to the ring. It's attached to a straight chain. Therefore, the parent will be actually this longest carbon. So, the parent will be actually propanol, 3-carbon aldehyde. This carbon will be number 1, 2, 3. So, over here, this will be your substituent, which is 3-cyclohexyl. So, bear that in mind. To have the name of the ring followed by the word carbaldehyde, the condition must be the C double bond O is directly attached to the ring. That is your cyclopentane carbaldehyde. But when the C double bond O is not directly attached to the ring, then it will be the normal aldehyde. So the complete name of this guy will be 3-cyclohexyl, 6-carbon ring as your substituent, attached to the parent of propanol. And that is the complete name. Okay? Simple. And I hope by now, you should be very good at naming your aldehyde because we'll be going into the naming of ketone. So everybody knows that the ketone C double bond O must be in between the carbon. So the general changes that we have is in your propane, for example propane, your E at the back in your propane changing to O-N-E. So propane to become propanol. That is your ketone. The O-N-E represent ketone. And propanol over here is a 3-carbon ketone, which is your C double bond O holding CH3 holding CH3. And this is the simplest ketone that you can have. Another example, your butane having the E changes to your O-N-E to represent your ketone. And butanol over here is a 4-carbon ketone. So the 4-carbon ketone shall look something like this. Your C double bond O holding CH2, CH2, CH3, like this. So there is a 4-carbon, 1, 2, 3, 4. So the question over here, do we need to put number in front of your butanol and propanol? In your propanol, you can see that your C double bond O is actually at carbon center. So which is your 1, 2, 3. Do we need to put 2 propanol? And in your butanol, you realize that to ensure that your C double bond O having the lowest number, you'll be calculating from the left, which is your 1, 2, 3, 4. Okay? So over here, do we need to put 2 butanol? Question mark. Yes or no? It's not needed to put the number because for the propanol 3-carbon, your C double bond O must be in the center to form a ketone. So your position of the C double bond O cannot be on the side because then you will have your aldehyde. Since it's a must to be in the center, so your propanol must be forever 2 propanol. Therefore, it's not needed to put the number. Same thing to your butanol, 4-carbon ketone. You realize that your C double bond O, no matter you are writing in this way, you will still be 1, 2, 3, 4. Your C double bond O will still be at carbon number 2. You realize that for your butanol, your C double bond O, no matter how you arrange in the center, it will still be carbon number 2, carbon number 2. Therefore, for the propanol and your butanol, it's not needed to put the position. So what happens when you have 5-carbon ketone? So start off with the first 5-carbon. Knowing that your ketone, your C double bond O, must be in between carbon. So the first in between carbon is over here. Complete the hydrogen. Another arrangement for the 5-carbon. And you realize that your double bond O can be moved to the center. Same thing, complete the bond. Can we still move the double bond O? Let's see. And I move the double bond O again towards the right hand side. And let's see whether it's correct or wrong. Complete the bond with all your hydrogen that is missing. And everybody over here is a pentanol because it's a 5-carbon. Right? 5-carbon ketone, so pentanol. But how about the position? So, for the first structure, the C double bond O is towards the left-hand side. Therefore, to ensure that your C double bond O to get the lowest possible number, we must count from the left. 2, 3, 4, 5. The name of this pentanol will be 2-pentanol. Because your C double bond O right now is at carbon number 2 and it's still ketone. Moving to the second structure, your C double bond O right now is in the center. And you realize that counting from the left or counting from the right will give you the same position. 1, 2, 3, 4, 5. So over here, this guy will be named as 3-pentanol. Why 3-pentanol? Because the C double bond O is located at carbon number 3. How about the last structure? So the last structure, you realize that your C double bond O look like changing position. But in fact, it's also carbon number 2. Because right now, we will be start counting from the right to ensure your C double bond O get the lowest possible number. So this will be also named as 2-pentanone. And you realize that they are the same. So not needed. And the question over here, do we need to put the number for the ketone? Yes, we need to put the position of the C double bond O when you have 5 carbon and above. When you have 6 carbon ketone, when you have 7 carbon ketone, then yes, you need to have this number in front of your parent name because you want to know the double bond O is located at which carbon. Okay? Simple. Let's try another one. Your 6 carbon, knowing that your 6 carbon is all hexanone. So let's see the numbering. So the first hexanone will be, the second hexanone can be, and can we still move the double bond? No, because you will still get the same number. And what would be the name of this hexanone? 1, 2, 3, 4, 5, 6. So over here, 2-hexanone. Because C double bond O located on carbon number 2. This one, 1, 2, 3, 4, 5, 6. 3-hexanone. So can you see that? When you have 5 carbon and above, alright, you need to have the position in front of your ketone. Remember that. Next, let's move to the IUPAC name and some common name in your ketone. The first one is your propanone. Your propanone is a 3-carbon ketone. Your 3-carbon ketone will also named as acetone. Acetone is the common name of propanone. Whenever the question mentions acetone, you know that it's a 3-carbon ketone. Another common name is your 1-phenylethanone. Your 1-phenylethanone is actually your acetone phenol with a benzene ring attached to the C double bond O CH3, 1-phenylethanone. And the common name that we always call it is acetophenone. Simple. 2 common names, acetone and acetophenone. Make sure you know this. Alright? Let's try some naming of ketone. One condition, C double bond O in the longest carbon chain must get the lowest number. That is the only condition. So always start with the C double bond O to find the longest carbon chain. So the C double bond O, one side you have no choice because it's only 1 carbon. Going down. So until this carbon, you have 3 choices, going to the left, going to the right, or going to the bottom. We always go for the longest carbon. So to the left. And then on this side, the carbon split again, going straight to the left or going upward will be the same because both having 1 carbon. So let's go outward. And we know that the C double bond O must get the lowest number. So always count from the side that give you C double bond O the lowest possible number. Count from the right. 1, 2, 3, 4, 5, 6. So over here, 6 carbon. And this guy will be your 2-hexanone as your parent because of the presence of 6 carbon and your C double bond O located at carbon number 2. So 2-hexanone. We have 3 substituents over here. Your methyl group that located on carbon number 3. Another methyl group also located at carbon number 3. Another one, you have your 5-methyl. Remember the prefixes that we are going to use? 3 similar substituents. Therefore, 3, 3, 5, trimethyl, 2-hexanone. Simple, easy. Another example, starting with the C double bond O again. So, on the left hand side, moving to the left, moving all the way to the left because there is no branches. On the right hand side, moving to the carbon and then having branches. same number of carbon, but going up right will give you more substituent due to the presence of bromo. Since it's the same number of carbon, we always go for the one that have more substituent. And C double bond O must get the lowest number. So my C double bond O over here must get the lowest number, counting from the left or counting from the right. Both will give you number 3. 1, 2, 3. 1, 2, 3. So counting from the left or the right will be the same in this case. Therefore, we will count from the side that have more substituent. So 1, 2, 3, 4, 5. And the name of this parent will be 3-pentanone. 5 carbon parent with the position of C double bond O located at carbon number 3. We have 2 substituents. First is your 1-bromo. Second is your 2-methyl group. And the name of this ketone will be 1-bromo, alphabetically B come first, followed by 2-methyl, followed by 3-pentanone. 5 carbon ketone with C double bond O at carbon number 3. Easy? So can you do the naming of ketone right now? It's very simple, okay? It's actually very similar to the IUPAC naming that we have been doing all this while. One last example. Again, we start with the position of C double bond O. Moving to the left, you have your CH, and then you have a cyclic. We know that's cyclic and straight chain. There will not be a gang. So move straight to the straight chain. On the right, moving to the right, 1 carbon, and that carbon having 3 directions. 2 carbon at the top, 1 carbon on the right, 1 carbon downward. So going top for more carbon. So that is my longest carbon chain. And my longest carbon chain right now deserves the position of C double bond O at the lowest number. So counting from the left or counting from the right. So counting from the left, obviously, because your double bond O will be at carbon number 3, 4, 5, 6. 6 carbon parent again. So the parent name will be 3-hexanone. 6 carbon ketone with the C double bond O at carbon number 3. Next, the substituent that we have, the first one, 2-cyclopropyl. Another one, 4-methyl, and another 4-methyl. And when I combine both of this, will be your 4,4-dimethyl. And what would be the complete name of this ketone? Bear that in mind, alphabetically order of cyclopropyl taking count of the C, for the dimethyl taking count of the M. Alright, the di prefixes will be ignored. So C and M, obviously, 2-cyclopropyl, because it's your substituent right now, dash 4,4-dimethyl, 3-hexanone, your parent. And that is the complete name of this ketone. Easy, simplest thing ever. So I hope at the end of this video, you can do the IUPAC naming of aldehyde and ketone, and also can differentiate which one is your aldehyde, which one is your ketone. Okay? The only thing that changed between them is the position of the C double bond O. Both of them are holding 1 C double bond O. Where is the C double bond O will determine whether it's a ketone or whether it's an aldehyde. Alright? So I think that's it for this video. Thank you for watching. Make sure you hit the like button and subscribe to the channel. I'll see you again in the next video, and thank you for watching.